The year is 1250, on a cold North Sea shore. You stand beside a Viking longship, its hull confronting relentless waves and driving rain. The Viking longship's keel runs long and narrow along hull length, directing water flow while maintaining lateral alignment through heavy seas, ensuring the vessel slices forward without excessive yawing or drag. Clinker planks overlap tightly along the Viking longship hull, allowing slight flex with each wave impact, enabling the hull to absorb energy without fracturing or separating along longitudinal seams. Iron rivets pierce each overlapping plank pair on the Viking longship, fastening them securely so hull integrity persists when waves strike, preventing the planks from peeling or loosening under repeated stress. The curved stem post rises sharply at the Viking longship bow, deflecting incoming waves upward and sideways, preventing the crashing water from striking the foremost hull planks directly. At the stern, the angled stern post of the Viking longship lifts slightly, countering backward water thrusts and maintaining hull stability by redirecting turbulence away from the rudder assembly. Oak timbers are selected for dense strength and used throughout the Viking longship hull, forming frames and structural members capable of resisting bending under both rower and wave-induced load. The Viking longship hull rises in camber amidships, allowing water striking the deck to run off quickly, minimizing pooling while preserving hull stiffness under transverse flex caused by wave motion. Gunnels on the Viking longship are raised just enough to prevent spray from entering the open deck, maintaining a clear interior for rowers while avoiding excess weight that could destabilize the vessel. Thwarts are evenly spaced along the Viking longship hull, distributing rower weight systematically so the vessel remains balanced and longitudinal. Bending under active rowing is minimized along the hull length. The mast step on the Viking longship is reinforced with solid timber and cross bracing, holding the tall mast securely against wind forces that push laterally and longitudinally, preventing hull distortion. Deck beams placed across the Viking longship hull connect frames, stabilizing the vessel and counteracting lateral torsion imposed by waves striking the hull side, maintaining longitudinal alignment under rolling motion. The Viking longship hull breadth is minimized to reduce drag, allowing the narrow vessel to move efficiently through choppy northern waters while maintaining stability against lateral wave impact. Bilgy planks installed low in the Viking longship hull direct incoming water toward the keel, ensuring drainage from the interior while reinforcing the lowest structural members against wave-induced compressive forces. Oar ports cut precisely along the Viking longship gunnel allow rowers smooth blade rotation without obstruction, maintaining stroke efficiency while avoiding contact with the hull planking or thwart edges. The tiller is mounted at the stern of the Viking longship, connecting to the rudder and providing leverage so small rower or helmsman movements precisely adjust hull orientation and currents. The rudder blade of the Viking longship is long and narrow, maintaining course efficiently by resisting yawing while the vessel encounters waves or wind, transmitting directional adjustments to the hull effectively. The joint connecting stem to keel on the Viking longship is reinforced with scarfing and additional fasteners, preventing longitudinal splitting under the repeated force of bow wave impacts. Plank thickness varies fore and aft along the Viking longship hull, allowing forward hull to flex under wave impact, while midship and stern planks resist bending, providing controlled longitudinal resilience. The Viking longship hull interior is cleared of debris and excess equipment, maintaining consistent weight distribution, so hull balance remains. Predictable and transverse tilting under motion is minimized. Thwart knees carved from curved wood absorb torsional stress on the Viking longship, transferring force between thwarts and frames, reducing the likelihood of hull twisting during uneven rower input or wave impact. Bow curvature on the Viking longship reduces frontal drag when cutting through breaking northern waves, deflecting water upward and sideways while preserving forward momentum without excessive hull flex. The open deck amidships on the Viking longship allows rowers to move freely, enabling oar coordination without interference from mast supports or rigging while maintaining hull longitudinal integrity. Strakes along the Viking longship hull are aligned at a slight angle, channeling water efficiently away from the hull and preventing pressure buildup against plank seams during wave impacts. Mast height on the Viking longship is calibrated to carry sail without capsizing risk, balancing wind force with hull stability, maintaining the keel and gunwale within safe lateral limits. Sails on the Viking longship are cut rectangular, providing thrust while evenly distributing pressure across the mast and hull, minimizing localized stress that could deform planking or frames. Oar length is matched to gunwale height on the Viking longship, maximizing human leverage, while rowers maintain proper stroke mechanics without contacting hull sides, preserving hull surface integrity. The Viking longship hull bottom is planned smooth, reducing water resistance and preventing turbulent flow from undermining longitudinal keel alignment or generating uneven forces along the hull. Keel timber tapers aft on the Viking longship, allowing the stern to lift over following waves while reducing drag and preventing downward bending or flex under wave pressure. Thwart spacing is adjustable along the Viking longship hull, accommodating varying crew numbers while maintaining balance and even distribution of longitudinal and lateral loads on frames. Plank grain orientation is chosen along the Viking longship hull to resist repeated flexing, with fibers aligned to distribute stress evenly under wave-induced bending. The Viking longship bow is reinforced with scarf joints, strengthening plank connections to prevent cracks from propagating under repeated frontal wave impacts or structural flex. Hull edges on the Viking longship are beveled, allowing planks to settle precisely without binding or creating gaps, maintaining continuous watertight overlap along the entire hull. The rudder pivot on the Viking longship is mounted low, increasing mechanical advantage for steering while transmitting helm input efficiently through water pressure without stressing the stern post. The mast step on the Viking longship is wedged tightly, preventing movement under shifting wind loads, keeping the mast upright while distributing vertical and lateral forces into the hull frames efficiently. Oarlocks carved directly from wood line the Viking longship gunwale, guiding each blade without friction damage, ensuring rowers transmit power efficiently while protecting both oars and planking from repeated wear. Bilge curvature on the Viking longship is shaped carefully to avoid water pooling amidships under motion, channeling liquid toward low planks while maintaining consistent hull contact and structural balance during waves. Stem height on the Viking longship is adjusted precisely, preventing wave overwash along the deck surface, allowing water to deflect off the bow while keeping interior thwarts and equipment dry. The Viking longship hull tapers aft, improving directional stability during heavy northern storms by reducing stern drag, maintaining longitudinal alignment, and preventing excessive yaw when following waves push against the stern post. Plank seams on the Viking longship are caulked with animal hair and tar, sealing water leaks completely, forming a continuous barrier that maintains hull buoyancy while resisting repeated flexing under wave force. Gunwales on the Viking longship are reinforced with rib bands, resisting outward pressure from waves, stabilizing hull sides under rower load, and preventing planks from bowing outward during lateral water impact. Stern post, braces on the Viking longship, connect diagonally to the hull, increasing torsion resistance under sail, transferring wind and wave forces evenly into the keel and adjacent planks for structural integrity. The Viking longship hull cross-section is rounded, allowing roll without sudden lateral stress peaks, distributing wave and rowing loads evenly across frames, while maintaining predictable hull response under dynamic motion. Thwart construction on the Viking longship integrates naturally curved timber, absorbing bending loads efficiently, transmitting rower force into frames while reducing localized stress on hull planks and minimizing deformation under repeated motion. Mast step placement midship on the Viking longship maintains balance between bow and stern, centralizing the mast's vertical load and ensuring even distribution of forces along keel, hull frames, and gunnels. Rudder angle on the Viking longship is calibrated carefully, allowing precise correction in changing current directions, transmitting helm input smoothly through pintles and stern post, while maintaining steady water flow along the rudder blade. Hull bottom strakes are thicker at the center of the Viking longship, reducing flex under rower force, stiffening the longitudinal axis, while allowing edges to flex slightly for energy absorption under waves. Bow plank edges on the Viking longship are trimmed precisely to avoid water catching on irregular surfaces, ensuring waves slide past without generating upward pressure that could separate overlapping planks. Oar blades on the Viking longship are tapered, minimizing resistance while maximizing propulsion efficiency, allowing each rower to generate thrust without striking the hull, gunnel, or adjacent rower oars during coordinated motion. Hull longitudinal beams run continuous along the Viking longship, distributing wave impact along the entire length, tying frames together while preventing localized bending or stress concentrations under repeated water force. The keelson of the Viking longship is reinforced with scarf joints, preventing longitudinal hull splitting damage, maintaining the integrity of the central backbone while absorbing bending forces from waves and sail pressure along the vessel. Hull frames are spaced precisely along the Viking longship, supporting planks against bending from wave pressure, maintaining alignment of strakes, and ensuring structural continuity along bow, midship, and stern sections under motion. Bow timber on the Viking longship is angled sharply, lifting the hull over incoming breaking seas, allowing water to pass below, while protecting planks and stem joints from repeated frontal impact. Stern timber on the Viking longship is reinforced with scarfing, resisting twisting from following waves, stabilizing hull alignment, and maintaining rudder function, while preventing deformation of aft planks under dynamic water pressure. Gunwale thickness is varied along the Viking longship, preventing flex under rowers' applied lateral force, stiffening hull sides, while ensuring the gunwale can absorb bending loads without transmitting cracks into planks. Plank fastenings are staggered along the Viking longship, reducing risk of simultaneous hull joint failure, maintaining continuous overlapping seams, and distributing impact loads from waves across multiple rivets and frames. Mast partners on the Viking longship are reinforced, supporting the mast under dynamic wind and sail loads, distributing vertical and lateral pressure to adjacent frames while maintaining central alignment amid wave motion. Hull chine on the Viking longship is defined clearly, directing water flow along length efficiently aft, minimizing drag and ensuring the vessel tracks straight while waves contact the hull sides. Oar port bevels on the Viking longship are smoothed carefully, avoiding blade catching during vigorous rowing, preventing stress on the gunnel, planking, and oars while maintaining uninterrupted stroke rhythm along each thwart. Stem timber length is extended on the Viking longship, preventing bow hull stress from impact, allowing waves to slide along strakes without concentrating force on the foremost planks or fastenings. Hull interior ribs are spaced evenly along the Viking longship, distributing torsional stress along each frame, maintaining shape under rower force, and reinforcing planks against repeated bending and wave impact. Rudder pintles on the Viking longship are bronze-mounted, allowing smooth rotation under heavy water pressure, transmitting helm input efficiently while reducing wear on the stern post and blade connection. The mast step of the Viking longship is reinforced with oak, resisting compression under sail load, maintaining upright mast alignment, and transferring vertical pressure safely into hull frames and keelson. Plank seams on the Viking longship are caulked with moss and tar, sealing water infiltration completely, preventing leaks during heavy seas while allowing planks to flex under longitudinal bending without losing cohesion. Bow strake on the Viking longship is thicker than surrounding planks, absorbing repeated impact from waves striking forward, protecting stem joints and adjacent strakes from compression or cracking over successive crossings. Stern strake on the Viking longship is tapered, allowing smooth water exit and reducing turbulence aft, minimizing drag and preventing eddies from pushing against hull sides or rudder blade. Hull crossbeams are wedged into Viking longship frames, maintaining longitudinal rigidity under motion, tying hull sections together, and transmitting wave and rower forces evenly across the vessel. Structure. Gunnels on the Viking longship are carved with a slight inward slope, preventing waves from spilling aboard, guiding water along the hull sides while maintaining deck dryness during heavy seas. Hull planks on the Viking longship are steamed before installation, allowing them to bend and conform precisely to the designed curvature, ensuring tight alignment along frames without introducing stress points. Thwart knees on the Viking longship are pegged tightly into frames, preventing lateral shift under rower force and maintaining consistent hull integrity during vigorous, synchronized strokes across the vessel. The rudder blade on the Viking longship is cut to match hull depth, controlling pitch as waves pass beneath, keeping the vessel level while transmitting helm adjustments efficiently to the stern post. Hull taper forward on the Viking longship reduces drag, allowing the bow to cut efficiently through choppy northern seas, maintaining forward momentum while limiting hull flex from wave pressure. Plank edge bevels on the Viking longship are made precise, ensuring tight overlap without compressing fibers, maintaining watertight seams while allowing controlled flex under longitudinal and lateral stress from waves. Mast partner angles on the Viking longship are cut to hold the mast upright, resisting lateral wind forces while transferring pressure into the reinforced frames and keelson without warping the hull. The keelson of the Viking longship is bolted continuously along its length, tying frames together, distributing forces from mast, hull, and waves evenly to prevent longitudinal deformation under heavy stress. Hull bow on the Viking longship is reinforced with extra strakes, resisting repeated pounding from surf, protecting the stem and adjacent planks from cracking under constant wave impact. Oarlock positions on the Viking longship are measured carefully, giving uniform rower leverage and maintaining hull balance, preventing asymmetrical loading that could twist frames or stress gunnel edges. Stern post alignment on the Viking longship is adjusted precisely, reducing twisting when waves strike from astern and keeping the rudder mechanically efficient while stabilizing the aft hull under motion. Hull interior of the Viking longship is cleared of loose material, maintaining predictable weight distribution along the keel and frames, ensuring even flex and minimizing unpredictable torsional stress during movement. Hull strakes on the Viking longship are bent carefully, matching curvature of frames and keel precisely, allowing the planks to sit flush without gaps while maintaining consistent hull shape. Thwart height on the Viking longship is adjusted, preventing interference with rowing or mast operation, ensuring each rower has clearance for oars while maintaining structural alignment with the hull. Gunwale braces are added along the Viking longship, resisting outward flex during lateral wave impact, stabilizing planks and thwarts while maintaining longitudinal rigidity along the vessel's sides. The rudder on the Viking longship is counterbalanced slightly, easing handling under sudden directional shifts, transmitting helm adjustments to the hull smoothly without overloading stern post or frames. Bow planking on the Viking longship is scarfed, preventing crack propagation under repeated hull stress, maintaining continuous longitudinal integrity across overlapping strakes while absorbing wave energy at the stem. Mast step width on the Viking longship is measured accurately, preventing lateral movement under sail pressure, securing the mast while transmitting vertical and lateral loads safely into hull frames. Hull frames on the Viking longship are notched precisely, seating planks tightly without additional fasteners, maintaining seamless overlap while resisting movement under wave impact or rower-induced flex. Oar length on the Viking longship is optimized, generating propulsion efficiently without striking hull edges, maintaining stroke consistency while preventing damage to gunwales and planking during synchronized rowing. Hull bottom planks on the Viking longship are smoothed, minimizing drag while maintaining structural strength, allowing water to flow evenly beneath the keel without creating turbulence that could stress longitudinal beams. Keel thickness on the Viking longship is varied along its length, resisting bending under dynamic water forces, stiffening midship for rower load, while allowing bow and stern to flex slightly over waves. Stern braces on the Viking longship are joined diagonally, distributing torsional loads from rudder operation, transmitting helm input safely into frames, and planking without concentrating stress at the stern post. Plank overlaps are staggered aft on the Viking longship, reducing leak risk during heavy seas by ensuring multiple seams do not align, distributing water pressure across the hull's longitudinal joints. Bow stem on the Viking longship is reinforced with scarf and cleat, resisting frontal stress repeatedly, preventing splitting under successive wave impacts while maintaining tight plank overlap along the stem. Hull camber is adjusted midship on the Viking longship, shedding water efficiently while retaining longitudinal rigidity, allowing waves to pass over the deck without distorting frame alignment or plank placement. Thwart spacing on the Viking longship is calibrated, supporting both rower weight and hull shape stability, maintaining even load distribution while preventing twisting or bending along frames and gunwale edges. Rudder pintles on the Viking longship are aligned carefully, avoiding binding under turbulent water flow, ensuring smooth helm control while transmitting force evenly to the stern post and hull structure. The mast on the Viking longship is positioned slightly forward, balancing sail force with hull stability, preventing excessive pitching or rolling while keeping the keel and gunwales properly loaded. Hull strakes on the Viking longship are fastened with iron nails, maintaining longitudinal integrity under stress, securing overlapping planks while distributing rower and wave forces evenly along frames. Bow planks on the Viking longship are bent and steamed, absorbing impact energy from waves without splitting, conforming to frames while maintaining a tight, water-resistant hull line. Gunwale height is modified aft on the Viking longship, preventing waves from washing onto the deck while maintaining proper clearance for rowers and mast operation. Stern post on the Viking longship is angled to direct water flow away from the transom during high speed, minimizing turbulence while preserving rudder efficiency and aft hull integrity. Hull ribs on the Viking longship are reinforced internally, maintaining shape under repeated wave and rower force, transmitting stress through frames while preserving planking alignment and longitudinal rigidity. Viewed together, the Viking longship emerges as a coherent system of interdependent structural adaptations. Every element, from keel to gunwale, responds to specific forces imposed by water, wind, and human propulsion. The long, narrow keel directs the vessel's path through heavy seas, while tapered timbers aft and cambered midship regulate longitudinal flex under wave impact. Clinker planks overlap precisely, reinforced with iron rivets and caulking, forming a hull both watertight and flexible, able to absorb repeated stress without fracture. Stem and stern posts, angled and braced, deflect and redirect water forces, preserving the alignment of planks and rudder under extreme conditions. Across the hull, frames, ribs, crossbeams, and keelson interlock in a continuous network, transmitting loads from mast, sail, rowers, and waves into the entire structure. Thwarts and their knees, pegged and spaced with deliberation, distribute rower weight and torsional forces along frames, while integrating with gunwales and planking. Mast partners, mast step, and rigging form a vertical system that balances propulsion and stability, calibrated to prevent excessive pitch or roll under shifting wind pressure. Oarlocks, beveled ports, and tapered blades coordinate with hull geometry, converting human energy into forward motion without compromising structural integrity. Every material choice, joinery method, and curvature reflects accumulated observation. Oak timbers for strength, steamed planks for precise fit, scarf joints to prevent splitting, angled strakes to shed water efficiently. The vessel's form embeds functional knowledge physically, encoding responses to repeated environmental and operational stresses. Viewed across generations, the Viking longship exemplifies a human pattern of embedding problem-solving directly into material forms. Each adaptation records a measured response to a predictable cause, preserving operational knowledge in timber, iron, and tar. In quiet reflection, the ship rests, not as a monument, but as a tangible archive of design, a vessel whose lines and joints testify to centuries of iterative understanding.